In our Wide World Importers database, a sales order is stored in two tables, one record in the sales.orders table, and for each order, for each item, one record in the sales.orderlines table. Now let's assume you want to retrieve all order information for a customer called Tailspin Toys, Little Creek, California, on July 17, 2014, if any. The simplest way to start would be to select from both orders and order line tables. It is also the wrong way. Don't run this query unless your machine is really powerful. The orders table has a little over 70,000 records, the order lines table 230,000 records. The result of this query is a Cartesian product combining each member of the first set with each member of the second set. Therefore, this query should theoretically return a whopping 16 billion rows. Instead of my machine with 64 GB of RAM, it returns an out-of-memory error. Each row of the orders table gets combined with each row of the order lines table, and that result is just too much to handle for most systems. This type of join is called a cross join. So as an alternative, we could have written our statement as follows. A cross join is not often used, however, and as you can see if you try to run the query, it can kill the performance of your SQL Server. In our case, besides performance, it doesn't make sense to combine an order with all order lines. We only want to combine an order with the order lines that belong to that specific order. In order to do that, we can use the where clause. Remember the table alias? We can use that to make the statement more readable. Now our result set contains a line for each order line and all information from the order it belongs to. That makes this a different join type, an inner join instead of a cross join. We're getting there, but this is still not the way to write a proper join statement. Let's add a restriction on order date. When we start adding more tables and more search criteria, it will become less apparent which predicate is for joining the tables, the join predicate, and which predicate is for filtering, the search predicate. To improve readability and decrease the chance of forgetting a join predicate, you should use the following syntax called an ANSI-style join. This way, you put the join predicates after the join statement and the search predicates in the where clause. We've now covered how to properly join two tables and two types of joins, the cross join and the inner join. We still have to cover the third type, the outer join. Whereas the inner join returns rows from one set with a match in the other set, the outer join includes records without a match. Let's find some data we can use to demonstrate this outer join. In the example of the orders and order lines tables, that would mean an order without order lines or order lines without a corresponding order. Given proper database design, it should not be possible to have an order line that doesn't belong to an order. Database design is covered in the next course, on exam 70762, but just a little glance ahead. The design of the order lines tables in the Wide World Importers database does in fact prevent order lines to be added without a corresponding order ID in the orders table. It does this by a construct that is called a foreign key constraint. This foreign key is defined on the column order ID in the order lines table. It references the order ID column in the orders table and dictates that you can only have an order ID that actually exists in the orders table. Quite often, a foreign key references the primary key of the table it references. A primary key is an attribute that is guaranteed to be unique and can therefore be used to uniquely identify each row. In the case of the orders table, that is indeed the case. Order ID is the primary key of the orders table. The order lines table also contains a column stock item ID, which, logic suggests, would be related to the stock items table in the warehouse schema. It wouldn't be strange to find an item in stock that had never been sold, so let's see if this combination of tables has the required data to demonstrate an outer join. We've seen enough of SQL to construct a query to select records in the stock items table that have a stock item ID that's not present in the order lines table. Unfortunately, there are no items in stock that have never been sold. Good news for the fictional company Wide World Importers, bad news for us. But we can easily make our own example of an order table and a customer table with data suitable to demonstrate the outer joins. That means we need a customer without an order and an order without a customer. So let's create a customers table and create an orders table. As you can see, the orders table has a column called Customer ID. When properly designed, this table should have a foreign key constraint, so we can only insert the customer ID of customers that actually exist in the customer table, but that would defeat the purpose of this whole exercise. We did add a primary key for reasons that will become apparent later on. So now we have the data, let's look at the three possible types of outer join: the left outer join, the right outer join, and the full outer join. A left outer join selects all matching pairs plus the records from the first table, the left one if you write the statement on a single line, without a match in the second table. As you can see, this query returns all records in the customer table with the matching records in the orders table. Customer number 3, Joe Johnson, has no order in the orders table. Therefore, all attributes for the order table are returned as null for Joe. The right outer join is the exact opposite of the left outer join. It selects all matching pairs plus the records in the second table, the right one, if you write the statement on a single line, without a match in the first table. Now, the result shows all orders, with null values for the columns of the customer table for the order without a match in the customer table. Obviously, putting table orders first in the join and customers second would have created the same effect as changing left outer join in right outer join. Now, for each customer we have at most one order. What happens if you add more records with a match in the other table? Let's find out. First, we'll insert another order for Bob, customer ID number 1. And now, let's rerun the left outer join query. Customer Bob now shows up twice, once for each of his orders. We've now seen the cross join, the inner join, and the left and right outer join. The final outer join type is the full outer join. This returns all records with a match in both tables, plus all records without a match. For now, we've only joined 2 tables, but you can easily join more tables. Let's create a third table, order lines, and join that table to the other 2. Or to be more precise, join that table to the result of the join of the first 2 tables. This only adds the order lines for one order. Feel free to add more. Now let's write a query to select all orders for all customers who've placed an order with order lines when available. This will result in the following query. To select all customers with an order, we need the inner join. And to select only the order lines when available and null values when unavailable, we need the left outer join. The result set will include all the ID columns, which we're not interested in, and makes the result too big to fit on the screen. So let's only select the columns we need. This concludes our demonstration of the different join types. We've shown you the cross join, which pairs at each record of the left-hand table with all records of the right-hand table, which can possibly lead to an enormous amount of records being returned, as the number of records in the result set is always the number of records in the left-hand table multiplied by the number of records in the right-hand table. The inner join, which returns all pairs of records that have a matching value in the column or columns you specify in the on clause. 3 different types of outer join, which return all records of the inner join plus records without a match in the columns you specify in the on clause. Which record without a match are returned depends upon the type of outer join. A left outer join will return unmatched records from the left-hand table, but not unmatched records from the right-hand table. A right outer join will return unmatched records from the right-hand table, but not unmatched records from the left-hand table. And a full outer join will return both the unmatched records from the left-hand table any unmatched records from the right-hand table. We've also mentioned the primary key and foreign key concept, but only briefly, because those are out of scope for this exam. Just remember that tables are often joined on the foreign key of one table to the primary key of the table the foreign key references. Now, let's clean up the demo tables before we proceed.